Oh. Okay. You can't take care of it. Just now. It's firing just fine. Testing, testing. Testing, testing. Hello everyone. Hopefully you can hear me. Ed is on the chat, so he's going to be taking care of any questions that arise during the webinar. Hope you're all doing well today. So just give me 1 second to verify a couple of things to make sure everything's in order, and then we'll go from there. Excellent. Okay, so I'm going to go ahead and bring up Fusion. Ed, let me know if you can see it. I'll try to keep track of the comments as they come in as best as I can. Okay, is everything good? Can everyone confirm that everything is working as it should be? Ed, let me know if you can see Fusion. Excellent. Hi, John. Hi, Peter. Okay, can everyone see? I just want to make sure before we start that everyone can see. Everyone see Fusion? Check, 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 check. Just making sure. Testing 1, 2, 3, testing 1, 2, 3, just trying to get confirmation that it's working. Testing, testing. Testing, testing, making sure. Testing. Seems like no one can hear me right now. Testing, testing. Okay. All right, everyone. Sorry for the confusion. Just wanted to make sure everything was working as expected. So right now you are looking at Autodesk Fusion 360. There was an update released today or late yesterday. So make sure that when you open up Fusion, you do get the latest version, and that it is working as expected. Now, the main thing I wanted to cover today in this live stream is setting up Fusion 360 to do electronics work. And basically what you're going to do is, the first thing we want to mention is setting up a libraries project and a trash project. A trash project is where files that you no longer need but can't delete will go. And this will serve as a way to get them out of your view, out of your way. Libraries is what we're recommending. A libraries project is what we're recommending that you use in order to organize your libraries in Fusion 360. So if we go into it, you'll notice that I have some libraries. I do have some extra stuff that I was just using for tests, but ideally you would only have libraries here, and then you would have a folder called 3D models, and then all of the 3D models that you plan to use in your libraries you could store here. Fusion doesn't really care where you store the different types of assets. You can really grab them from anywhere. So the key is really looking for a way to kind of keep the projects homogeneous, same types of files in one view. So you would just have libraries here, and 3D models, you would just have 3D models. Some team members like to make another folder for data sheets, for PDF data sheets. You can do that as well. The main idea is to kind of compartmentalize everything. So if you do it this way, you keep all your libraries central, and it's easy to know where the different design assets are coming from. So you know where your schematic symbols are coming from, your 3D footprints are coming from. All of that is going to come from this project. If you decide to save your libraries in at a project level, so each project individually has its own libraries, that makes reuse a little bit more difficult, and it can be hard to tell where a specific part came from. Did it come from a project? Did it come from a main library? Did it come from one of the ones that Autodesk provides? By kind of keeping everything centralized, it's easier to keep track of things. So this is our recommendation. This is what we're recommending to users to do. Make a libraries project. If you want to pin it so that it's always at the top, that's a good suggestion as well. But this will kind of help clear clutter. Now, if you've been using Eagle before, one thing you could do is you maybe have scripts and UOPs that you've used for many years. You can do a similar thing. You can create a project for them, and then that way everything is centralized. The benefit of projects is that it makes sharing really easy. So if you have a libraries project, you can just go to people and you can invite your various team members. If you look at the data on the web, you have more options to control. So you can specify if someone can, for example, contribute to the library, if they only have read-only access to it. So these are all features that help you manage your team workflows when you're using Fusion 360. So this is what we're recommending as far as libraries and setting up your projects for working in Fusion 360. Now, if you come from Eagle, there's basically two ways to get libraries into Fusion 360. And which way you use is going to depend on the content of your libraries. If your libraries never had any 3D associated with them, if you never made them managed before, then the best approach is to use the upload button. Okay? So that's one method. That's method number one. If you never had 3D content in your Eagle libraries, use the upload method. If you did, then the workflow is going to be different. You're going to basically use the linking functionality to bring your managed library into Fusion 360. Now that's a topic for another video. That's something that we've discussed actually in a previous webinar. But for now, it's enough to highlight that if you have managed libraries, then the workflow to use is different than if you never had any 3D content in your Eagle libraries. If you never had any 3D content in your Eagle libraries, upload is the way to go. Now the other thing you'll notice is Fusion sorts everything alphabetically and in numerical order. So for example, if I have key projects that I want to keep an eye on or that I frequently intend to visit, then just prefixing a 1 at the beginning of the project name, it's enough to be able to push it towards the top. So you'll notice these are like my main projects, and then I have some other stuff, some other different miscellaneous things that pop up and things like that. Okay, but anything key, you can prefix with a number, and that will help organize the design. Now, if you go into a design, you're going to see that maybe your contributors have added other things. You have the option to add folders within a design. You'll notice this was pre-setting up the workflow that I just described, so it's a little bit messier. There's a lot of extra things here. And it's this type of situation that many of our users find themselves in when they're first starting off with Fusion 360. It's having a folder or a project that has too many different types of objects in it. And the way you can avoid that is either adding additional folders, or if you set up, like we recommend, a libraries project and having the 3D models folder in it, now none of these other projects should have 3D models in them or libraries in them, and that's going to make things easier for you. Okay, so something more proper would be like what we're seeing here, where we just have the assets that are specific to design. So we have the enclosure, we have the electronics design data, and you're going to put that in a project. So if you're strictly doing electronics, what you'll probably find is that you just have these 4 types of files. You have this one, which is the electronics design. You have the schematic, you have the 2D PCB, you have the schematic, and you have the 3D PCB. Most of the time, you'll have these 4 files. Maybe sometimes only these 3, because only these 3 are strictly electronics related. But if you do any type of mechanical work or enclosure with your intelligent products, then you'll probably have a 3D PCB as well. Okay, but this is the fundamentals of working and organizing your projects in Fusion 360. So to recap, create a libraries project, store all of your libraries and your 3D models within that libraries project. This is going to make it easier to share with other team members, and it's going to keep everything in one place. So we definitely recommend doing that. Also create a trash project. That way if there's files that can't be deleted because they maintain too many associations, it's easier just to move them into this trash project. That way they're out of the way and you don't have to deal with them anymore. When working on an electronics design, you're going to want to go ahead and make a project, and within that project you're going to create an electronics design file, which is very simple, file, new electronics design, and then from there, as you work, you're going to end up creating these additional files, which will be a 2D PCB, a schematic, and possibly a 3D PCB. those are the fundamentals. Those are the basics. You have a filter here at the bottom, so if you end up over time having many projects, you can actually just start typing and it will try to filter the list down. Okay, so you can see it makes it really easy to keep track of that information. Now, another thing that we can do from here is we want to talk about creating a library. This is something that as of late is creating a lot of difficulty for users. So I'm actually going to go through the process of designing a part from scratch, showing you the various options step by step. Okay, so I'm going to click here, File, New Electronics Library. Okay, and you're going to be greeted with this view. Now, what do you do from here? The first thing that's important to understand is that libraries contain basically 4 different types of assets. Okay? They contain devices, symbols, footprints, and packages. Symbols are the schematic representation of a component. Footprints are the 2D representation of a component. A 3D package is the 3D representation of said component. And then a device is what maps everything together. Okay? So what we're going to do now is we're going to go ahead and start by making a symbol. The order isn't too critical, other than the device is going to be the last one. Okay, the device is going to be the last object you see. So bear with me 1 second. I'm getting reports of some lag. Give me 1 moment. Okay, so let's go ahead and start by making a symbol. Now, symbols are arguably the easiest asset to make. So we're going to say create new symbol. I can import an existing one. So I can go to import, and I can grab something that's already in Fusion 360. But in this case, we're going to make it from scratch. So I'm going to give it a name, and I'm going to say op-amp. Okay, I'm going to say OK. Now, the key thing with symbols and anything related to the schematic is to stick to a 0.1 inch grid. If you prefer the metric system, just change the units to be metric. It'll be 2.54 millimeters, but don't deviate from that amount. And the reason for that is that if you deviate from that grid spacing, it's going to make it difficult to connect things on the schematic. Now, we do have a pin snap feature, so that it does make things better, but connecting to nets on the schematic doesn't use a pin snap. Okay? So let's go ahead and just knowing that we're going to stick to the 0.1 inch grid, we're just going to draw a basic op-amp. I can use the line command. Okay, I'm not too concerned. I'm going to change the bend style, so control right click to change the bend style and just bring it there. Now, another key thing, and this is in general, when making symbols or making packages or making footprints, we highly recommend centering the object that you're drawing. Okay, center it around the origin. Because when you go to place this in a schematic or in a 2D PCB, this is going to be the handle. This is going to be your grab point for the component. So make sure that you center your components. It's just going to make things easier down the road. So for now, I'm going to click pin. I'm going to place these. Don't worry, I know it doesn't look very nice right now. We're going to change that in a second. Okay, so it's just these 3 pins for now. And this is a single op-amp. Now, what we can do is you can click on the individual pins and you'll see all of its properties. So I'm going to say out for this one. Okay, I can click on this one. I can say plus. Hit enter. I can say minus. Hit enter. Okay, and you'll see that we have other things that we can do. And this is probably the most intuitive workflow, just going to the inspector and making the changes. There are ways, if like for example you have many pins and you want to do changes all at once, the change command can help you with that. So you can, for example, set visible. In this case, I'm going to set to only show the pad. And I don't care to see out because as part of the nature of the op-amp symbol, you already know that's the output. So I don't care to see that text. But because I have change active, I could do the same thing to this pin and this pin. So if you need to do something to a lot of components or to a lot of pins, the change command is a way to do it all in one go. Okay? So I'm going to go ahead and undo those last two operations. Now, it's worth mentioning all of these properties that are here. We should talk about them. Okay? You'll notice position is self-explanatory, angle, direction warrants some explanation. If you click on direction, you're going to see that there's several options. And what these options are used for is in the electrical rules checking. Okay, if you set a pin to be IO or to be pass for passive, those don't get any special checks. But the others do. So for example, I know this is the output of the op amp, so I'm going to change it to be an output. And I know these two are inputs. So I'm going to set it to be inputs. And when you specify what a pin is, special checks outside of the IO and passive directions, special checks are applied. So for example, because I've set the op amp's output to be an output, if Fusion Electronics sees that multiple outputs are connected together, then that'll flag a warning, because normally that would create a problem in the circuit. So by setting a direction, you enable the ERC to help you and look for design errors. Now, swap level. What does swap level mean? Swap level is used to indicate if pins are interchangeable. Okay? And this concept is actually also used at the gate level when we go to the device. So just remember that. And the way swap level works is 0 means the pin is unique. It can't be interchanged with any other pin on the device or on the symbol. If you have a number greater than 0, then any pins that have the same swap level are interchangeable. So for example, if you look at a resistor, you would notice that both pins in the default libraries, they have a swap level of 1, which means that they can be interchanged because they're functionally the same. In the case of an op amp, that's not possible. So we leave swap level at 0. Length specifies the length of the pin. So by default set to middle.